almost more than 80 people around, or I don't know how many are here in this session. I'm sure that some of you never heard of this feature, or perhaps heard it, but know not exactly what it means. That's why I start with some basics, just for the first few slides, to explain what query rewrite exactly is and how it works in general. The idea is that we have a materialized view, for example, a join of these three tables, product sales times, and typically a group by or something like that. So there are different ways to create a materialized view. And the idea is that the result of the contents of this materialized view is the result of the query on these three tables. So we create the materialized view with as select from these three tables. And then, of course, we have the possibility to select directly from the materialized view. But what we do here, or what Oracle does when we enable query rewrite, that means that we just write a SQL query on our base tables and let the optimizer decide whether it has to read the data directly from the base tables, which means additional joins, typically much more rows to read, or when the query is in the right form and all the conditions are fulfilled, it is able to rewrite the query and select the result from the materialized view. There are several restrictions. Of course, the materialized view has to contain the current data, so it has to be fresh. We will come to that later. And it is not possible in all cases. So, of course, the simplest way is when the query is exactly the same in the materialized view definition and in the query I run in my session, then it's obvious that query rewrite is easy to do. So here a simple example as an introduction. So I create the materialized view on these three tables, group by calendar month and product name. All the examples I show here are based on the SH demo schema, so on the sales history schema of the Oracle. So that's my materialized view definition. The important line here is I have to tell Oracle, okay, you can use this materialized view for query rewrite. So I explicitly have to enable query rewrite. And then if I run exactly the same query, then the query is rewritten. And when I look at the execution plan, I see it's not a join on three tables. It's just a materialized view rewrite, access full in this case. So the more or less a full table scan on the materialized view that was created before. This example here, that's the easiest way of materialized view, that's called query rewrite. And query rewrite with a full text match. And that means if the query is identical in the definition of the materialized view and in the query, then it's very easy. But of course, that's not the only way to do it. There are other options, as we just will see on the next slide. There are two parameters that are important if you use query rewrite, that they are set properly. The first one is already the default value is what we need here. The parameter is called query rewrite enabled, and it has to be set to true, which is normally the case. And true means if the query rewrite is, or if a materialized view is available with enabled query rewrite, and this parameter is true, then the optimizer can use this materialized view for query rewrite. I say can because it always depends on the costs. If there is another plan that is cheaper, then the other plan will be used. But the typical case is that the materialized view is used then. Force means the materialized view is used in all cases, even if the costs are higher. Force, yeah, and false means the feature is disabled. That's what we don't want here in this session. And the second parameter I will explain later in more detail. Here we can, for example, this defined about the freshness of the materialized view. That means by default, query rewrite works only if it contains the current data. So that's the default value in force. If I set it to stale tolerated, which I would not recommend in most of the cases, that means even when the materialized view is stale, that means the data is outdated and does not fit with the current data in the base tables, then query rewrite would work. But of course, the result of the query is not the same as if you go to the base table. That's why you should be very carefully to set this parameter. And then there is another value called trusted, which is more or less the same as enforced, except some changes in combination with constraints and dimensions. That's also a parameter I will explain in this session later on. What we already saw in the first example is the full text match, the obvious way of query rewrite, and similar is the so-called partial text match. That means we still have the same query, but the select list is not exactly the same. So I can change the order of the attributes, or only a few attributes are in the select. But that's also not very interesting. What we will look here is the so-called general rewrite, or in the Oracle documentation, Oracle writes about advanced query rewrite. These are several features that were introduced in multiple versions of Oracle, going back or starting from Oracle 8i till 19c. And some of these features I will show you and show how they work. And that's the thing we will look at on the next few slides, and then with a live demo how this really works. So some of these features of the advanced query rewrite possibilities. For all the examples, I use this materialized view here. So also materialized view on the 3 base tables like before, but slightly different. So I select 3 columns and then have the sum of amounts sold, and then 2 counts. I don't care about why we have these counts here. That's not important here for the moment. And then we group the data on calendar month, product ID, and channel ID. And here on product ID and not on product name. And that's exactly what I want to show you with the first feature called join back. When I run a query, but I don't want to show the ID of the products, but the names and some other columns of the product table. That means this data is not available in the materials view. And in this case, Oracle would be able to do a so-called join back. That means it reads the materialized view, but does an additional join then on the products dimension to show the additional columns of the dimension table. And the second example I will show you is the so-called aggregate computability, difficult word. I have the sum of column amount sold on the sales table, and also the number of rows where amount sold is filled for this query, so the count. But in the query, I ask for the average. And as you probably know or learned in school, the average is the sum divided by the number of rows. So sum divided by count is average. And although the function average is not part of the materialized view, Oracle is able to calculate it on the fly from the existing functions that are available. That's not only for average, also other functions, but in these examples, I show it like this. Then the third feature of advanced query rewrite is called a delta join, a materialized view delta join. If I select only two of the three tables, in some situations, not in all of them, but in this situation here, for example, I'm not interested in the calendar dimension or in the times table. I just want to read the amount sold per product name. And in this case, hopefully the materialized view will also be used. There is a precondition called a lossless join. That means it has to be guaranteed that we don't lose any data if we do an additional join on a table that is not used here in the query. And that should be the case here, because it doesn't matter whether I join the date of the transaction or not. It should not change the result at all. And the other form of delta join is the so-called query delta join. That means if I join an additional table which is not part of the materialized view, here channels, then the materialized view can be joined with the can be read and must be joined with the channel dimension on the here in the same demo schema. The precondition here is that the join key, so the sales, no, what is it? The channel ID must be part of the materialized view, which is the case in our example. Okay, let's see what this means in reality. So I created here this materialized view on my local database. And the first query I run, so these are all the queries I showed you before. So the first one is we have this additional 3 lines here. From where is my mouse? I always have problems. Teams and mouse. Zoom and mouse seems not to work out. You can see at lines 3 to 5 and 11 to 13 are columns that are not part of the materialized view, and therefore a join back should be executed. And that's what we see here in the execution plan without going in all too details. But you see in line 6 that the materialized view is used, so query rewrite worked. And there is a join with the table products in line 3, and the join is in line 2 then. So that seems to work. The second example that I show you, the one with the average. When I run the average, then we don't see that the sum and count were used to calculate the average, but we see that the materialized view worked in line number 4. The materialized view delta join, so we omit the table times in the query. It also works. So again, the same execution plan as before. So line 4 shows the query rewrite, and the query delta join on 4 tables. 3 of them are part of the materialized view. And here it seems we have a problem. What happened here? Why does materialized view not work? When we go back to the materialized view at the very beginning, here I forgot to create the channel ID as part of the materialized view, and the impact is that sorry. Yeah, that query rewrite didn't work. So I when sorry for that. Everything is part of the query of the live demo, so I didn't. Yeah, so that's the query of the materialized view. So it does not contain the additional join column on the channel table, and the precondition was materialized view must contain the join key, which is not the case. Therefore, I drop and recreate the materialized view and run the query again. And if I run the same query again, now we see that in line 8, query rewrite works. And in line 5, the channel dimension is also red. Products dimension, because we have the product name, which is not part of the materialized view. So that's the join back feature, the first I showed you. So here, 2 of these advanced features are combined. Okay, that probably went a bit fast, but I think it's important to see all the different ways of these advanced features. But there is more that is available, especially for examples like this on a star schema, where we have a fact table that joins multiple dimensions or dimension tables. Then we have another issue, and that's called roll-up. When we do a group by on different levels of the dimension hierarchy. For example, here on the calendar, we have a materialized view with monthly aggregations. That means we have the total for every month, but we want to know the total per year or the total per quarter. And the question is, how can we do that without creating a materialized view for every distinct level on the calendar hierarchy or any other dimension table? So the question is, does this query in the yellow box, can it use materialized view? Can it use query rewrite when the materialized view contains only the calendar month but not the year? It works, but to understand how it works, we have to introduce another feature. Oracle calls that the dimension, which is not the same as a dimension table. I would call it a kind of hierarchy constraint. This is an additional definition in the data dictionary, some additional metadata to tell the optimizer what is the relationship between the different columns of a dimension table, which column belongs to which hierarchy, and what hierarchy at which hierarchy level, and which what is the relationship between these hierarchy levels. So we can define that a day belongs to a month to a quarter to a year, and then we can define for every hierarchy level which columns belong to this level. And if we do this for all the dimensions, then we can run such queries like here, and then we see here, at least on the slide, that query rewrite seems to work. But does it really work in reality? That's the second demo. I create that not only for the times dimension, but for all dimension tables. So on product, we, for example, can say a product belongs to a subcategory, and the category belongs to a category, a subcategory to a category. Then we have some promotions, we have channels, and so on. And here is the one we need for our demo, and we can see that can be quite complex. Here again, the problem that my mouse doesn't work. So we have 7 levels or 8 levels, but not all belong to the same hierarchy. So in this case, we have a calendar hierarchy, And we have also a fiscal year hierarchy. So things like that can be defined. So 2 different hierarchies, and then for every attribute has to belong to exact 1 hierarchy level of the hierarchies then. Customers, here is an example where we can even do a join on a different table. So if we have a snowflake schema, so there are multiple options how we can create this query rewrite or these hierarchy constraints. And now for our example we showed before, so we, of course, when we do a group by month, then it does query rewrite as expected. We don't need this additional hierarchy information. But if we go by group by quarter, it seems not to work. So times and sales is red and not the materialized view. The same on year. So even with all these dimensions we created, it does not work yet because we missed one little detail. And that's this parameter I showed you at the very beginning. Query rewrite integrity, we have to set this parameter to trusted, and trusted means we have to tell Oracle, okay, you can trust that my hierarchy definitions are correct because they are not proved. It's not like a real constraint. And in this case, if my definition is wrong, that would result in different results of the query. And to avoid this, we have really to make sure that it is correct. And if we know that the data is correct in the calendar dimension, then we can set this parameter to trusted. And in this case, it should hopefully work. On month, it was working before, but also here on quarter and on year level. So if we do a calendar year, then we see, okay, the query rewrite works, and then there is an additional join with the join condition on calendar month. So the year is, now we read the month description from the materialized view, which is also available in the times dimension. We can join with these 2 columns then, and then select the year of the of every date that is in this particular month. And obviously that's faster to add 3 or 12 lines of a materialized view to have the total per year instead of reading 1 million rows or a couple of million of rows on the fact table of the, in this case, the sales table. What happens if the materialized views are stale? So if we change any data, then the materialized view does not work anymore because it would not return the same result. We can avoid that either by refreshing the materialized view. That's what I not explain here in details because there are that will be another session, but I will show you where to find this information at the end of the presentation. And or we could set the parameter query rewrite integrity to stale tolerated, which I do not recommend, as I said before. Or we can use real-time materialized view, a feature that was introduced in Oracle 12.2, but I think it's rarely used so far. But it's actually a very interesting feature, and that's the next thing I want to show you in detail. What I can do, I can create a materialized view, which is fast refreshable. It also needs materialized view logs, as we see in the demo afterwards. And we have additional parameter here that we say enable on query computation, and that means if a query is executed and the materialized view is stale, then the last data of the materialized view is used as a base, and all the missing data or the change data are read from the materialized view logs. So like it would be with fast refresh. So of course it's not as fast as if I can go directly to the materialized view, but it is still faster than to read the base tables. When Oracle introduced this feature, of course, that was one of the things I tested with this, or with even a simpler example, but here just to show how it works. So we create on each of the base tables, we have to create a materialized view log. That's what we typically do for fast refresh, but it's also used here for these real-time materialized views. Then we create the materialized view again, or a simpler one like before. And important here is line 4, enable on query computation. That means we have a real-time materialized view. I create another materialized view, also real-time materialized view. The first one is a join of sales and products. The second one on sales and times. Of course, I could create the one with the 3 tables like before, but here I have 2 separate ones for, you will see later then why I created 2 of them, or what is the difference. Both of them are fresh. That means the data is current, and if I run some queries, then query rewrite works as expected. So here, that's basic query rewrite, so very simple. That works wonderful. Now I change some data. I insert 1 line in the sales table. So we already had 1 million rows, but 1 row is inserted now for one particular transaction. And that has an impact on materialized views. They are now stale, or the staleness is either stale or needs compile. Here it's need compile. And that means query rewrite looks different now. And here we have a very interesting execution plan. Looks much more complicated than before. And what here is done, so without going into details, so we see that the material, that's really sad that I can, here now it seems, yeah, just don't see the, here. Data is read from the materialized view log of the change table. That means this missing transaction is read from there. And then some other data the same. And finally, in one place, here on line 17, there is the materialized view is used. And what we see here, without telling all the details, it does a full auto join of the materialized view with all the changes on the base table, and can find out what was inserted, what was updated, what was deleted, and therefore can return the correct result. And then I do that for the second materialized view, and here it took quite a while. But the problem is, after a while, after about 10 seconds, we get an error message: object could not be validated or authorized. I could not find out the reason why it works in some cases and it doesn't work in other cases. It took me a lot of time to find out how to find an example where at least one of the examples, a very simple one, worked. So it seems that this problem is not yet solved. So I'm on a 19C, no, even on a 21C database, but the problem still occurs. And if I refresh the Materialized view, then it works again. That's the same as the beginning. I have to hurry up a little bit. I'm out of time almost. So here, it's a very cool feature, but it's not yet finished. So when I did my tests about almost 2 years ago, then I opened a service request to explain this problem. And in the meantime, they at least found out that other people have the same problem, so they created a new bug and found out it's a duplicate. But I'm still waiting for a result from Oracle support since almost 2 years now, so the problem is not yet solved. One day we will hopefully have a patch. Okay, I think I skipped this part, otherwise we get out of time. No, I think that's the 19C feature. I will show it, otherwise the newest one will be missing. So we have something we call a count distinct challenge. The problem is we have different kinds of count distinct queries. For example, we want to know how many distinct products we have for a particular promotion ID and a sales channel. But we also want to have the count distinct only on promo ID or only on channel ID. And the challenge is to find a Materialized view that can help in all these 3 queries here. To show the different possibilities, so the first thing I do is I create a Materialized view with for the combination of promo ID and channel ID, and do a sound count distinct on prod ID. And when I run this query that groups by both of the dimension keys, then it's exactly the same query as the Materialized view. So that should work. Yeah, query rewrite works as expected. But what happens if I do only a group by promo ID without channel ID? Then it doesn't work. It would work with a normal count. Then we have the delta join, which I showed you before, that no, not we don't even do a join here. So no, then it will be just 2 of the 3 columns of the Materialized view. So that would work. But with a count distinct, the result is different whether I do a distinct on both IDs or only on one of them. Therefore, it cannot be answered with this Materialized view. And the same the other way around. If I select only channel ID, then it also goes to the sales table without doing a Materialized view. Of course, what we can do, we can create 2 additional Materialized view for the second and the third query. But that's not the idea. Of course, this works. In this case, the first still works with the original MV sales distinct Materialized view. The second one works with a distinct per promo Materialized view. So we use another Materialized view. And the third one needs also another, but it's not a nice solution to have a Materialized view for each individual query we run. So that's definitely not the idea of a good design of Materialized view in a star schema. So is there a better way, or a way that we can use only one Materialized view instead of 3 separate ones? And that's what we can do with some new functions that were introduced with 19C. So this bitmap bucket number and bitmap aggregation. So it's a bit difficult to understand what this function return. And if you read the documentation, here's just a summary of what you can find in the Oracle documentation. So there are a total of 5 bitmap functions, that bitmap-based count distinct functions they are called. And each of them is explained what it returns, but it's not obvious what they can be used for. And it took me quite a while to find out how this works and to find additional information. In the meantime, you find several blog posts about it on the internet. But when I did these checks, so when 19C was completely new, no information was available. In the meantime, even Oracle has some examples in the documentation where you can see what is the purpose of all these functions and how they can be used. But the story, the short version of the story is these 5 functions, here 3 of them are used, can be used to create materialized view that create kind of bitmap arrays for distinct values, and they are helpful to fulfill query rewrite with count distinct. So if I go back to my demo and run my 3 queries again, so all of them use the same materialized view, this 19C materialized view here. So we don't need separate materialized view for each count distinct, so they can all be answered with the same MView. Okay, now I showed you several features, but the typical problem with query rewrite is that if it works, nobody cares about it, then it's a nice feature. But what do we do if it doesn't work? So how can we find out why query rewrite didn't work? For this, of course, we can read the Oracle documentation. That's also a good idea, as I will show you at the end of the presentation. But we can also use 2 procedures in the DBMS MView package. That's the same package that is also used to refresh materialized views. And the first of the 2 procedures is called the explain MView procedure. And what it does, it analyzes a materialized view, so it finds out what of the specific features are possible for this materialized view. So that's not only query rewrite, there is also fast refresh and so-called partition change tracking if we have partitioning in place. And then, so here we can see at least whether a query rewrite would work in general or what we have to do if it doesn't work. The result of this procedure is written to a table, MV capabilities table, which we can create with a script at the beginning. And the second materialized view, I will skip the demo, but yeah, the second one I think I can show you is explain rewrite. And explain rewrite here, the parameter is not the name of a materialized view, but the query we want to execute. And Oracle tells us also in a result table here, in a rewrite table, whether query rewrite worked or not. And when it doesn't work, then it shows what was the reason that it didn't work. . Okay, explain rewrite. This is my materialized view again, the same as at the beginning. And the rewrite table, which is created with this script, contains just a simple table without any constraints or anything on it. It's just to store the result of this explain rewrite procedure. And now I want to execute the query with average here. I create a CLOP variable that contains this query and execute the explain rewrite procedure. And then I can read the result, and we can see here in the rewrite table, query did not rewrite. That means there is a specific reason why query rewrite didn't work. And the reason is explained in the next two lines. So we cannot compute the average. Okay, why? Because for the other problem is we also need a join back to the product table, because we have the product category, which is not part of the materialized view. But the problem here is the average cannot be calculated. Why that? Because I missed the count part here. So that's that helps me to find out the reason. And if I recreate the materialized view again, and now I also add the count column, or the additional column that calculates the count, then I explain the rewrite again. And now query was rewritten with this materialized view, and we still have the information that the join back on the products table was performed for this query. So that's really helpful. And for me, I use these two explain procedures quite often to find out what is the reason when it didn't work, what do I have to change in my materialized view, or which parameters I have to change, like query rewrite integrity to trusted and all things like that. Or when the materialized view is not fresh, all these things would be explained here in the two procedures. Okay. The last part, design tips for query rewrite, I can go through it quite fast, because you can read the details on a blog post. So I skipped the next three pages here. The most important message here, or the most important design tip: take some time to read the documentation. I know that all of you, and also me, we are always looking to the Oracle documentation when we have a particular problem and search for a solution. But before you ask a question on Stack Overflow or things like that, a lot of questions can be answered when you carefully look at the documentation, and especially in the data warehousing guide. In the part 2 called optimizing data warehouses, there are several chapters about materialized views and query rewrite, and that's really something that is very nice to read. At the beginning, it was quite scary with Oracle 8i. So a lot of the things were not clear, or at least for me to understand what it means. But now you find for all of the features, you find nice examples and even links to live examples and additional information. So that's really something I can recommend. And these design tips, which I skipped now, are also available. So about a year ago, I wrote a blog post, design tips for query rewrite, which is read quite often, as I see in the statistics on WordPress. If you go to danishniederwordpress.com or directly to the link here that you see on the slide, you will get the presentation later on anyway. then you have all these links available, and there you find detailed descriptions of all the design tips I just skipped here at the end of the presentation. Okay, so we have some minutes left, but we can take some time more if you want. I saw there were already a couple of questions, and if I find my Zoom session again, yeah, then
yeah, Dan, there are a few questions.
Yeah.
If you can just pick.
Yeah, I just have the problem that I cannot find the Zoom window anymore.
Okay, maybe unshare, and maybe you
Yeah,
can.
I think that's what I should do now. Ah, here we are. Huh? Okay, then let's go to the session. So I share again, and 15 questions, so I have to hurry up. So the first question is, what if you don't enable query rewrite while MView creation? In this case, the materialized view is invisible for the optimizer. So if you don't specify the enable query rewrite, the materialized view is created, and you can run selects directly on the materialized view, but you cannot use it for query rewrite, or the optimizer cannot use it for query rewrite. Next question, what if we don't write? Oh, no, that's, okay, they don't disappear. Then what reason we have to do or advantage of query rewrite with false option? Yeah, what is the purpose of the enabled, if we say query rewrite enabled, not true or false, but false. False is, I explained that in the presentation already, false is this, so query rewrite is enabled, but unlike the default behavior with the optimizer, that the optimizer always uses the cheapest execution plan, it would always use query rewrite even if the query rewrite seems to be more expensive than the select on the base tables. So in most of the cases, there is no difference between true and false. And to be honest, I never used false in a real project. It's just nice to test whether query rewrite would work anyway, but it's not so. It's not an important feature. So most of the time, it's either true or false. What is the difference between trusted and enforced? That's what I showed with the hierarchy constraints. So trusted is we have to tell the optimizer to use these additional constraints. So I think a lot of these questions were asked before I explained the feature. So I just, to make it faster, I say I answered it in the in the presentation. In a PL SQL package, if I write a SQL like select from materialized view now, and how that differs with writing the same with query rewrite. So the difference is if you select directly from the materialized view, then the materialized view is just like a normal table. So the only difference is that the content of this table is not loaded by some code that you wrote manually, but with the result of a select statement. And then you can refresh these materialized views and so on. But query rewrite means you don't do so for the use of the query rewrite or the name of the query rewrite is not important. It's something that is done automatically by the optimizer. So you can compare it like an index that is created, so the users don't care about whether they select through the index or directly to the table. The decision is done by the optimizer, and that's the same here with query rewrite.
Then you also need to pick a couple of few people if you feel that it's a really good question.
Yeah. Till now, I think there were not many. Yeah, there were just obvious things that you can read in the documentation. Is the query rewrite option, can it be used only with Materialized View? Of course, that's what I explained. So we involved average function in query, where sum and count is part of the Materialized View, and that is transformed. Then has this been introduced in 19C? No, that was I don't know exactly in which version this computer aggregation computability was introduced, but I think very early, so at 8i or 9i or something like that. So that's something that works since long ago. Sometimes Materialized View is very slow. What are the approaches we have to consider to tune it? That would be another session to go into details. Some of the tips you find on the last 3 slides or on the blog posts, but I think that's one of the questions I would mention as a good question, because that's something I do quite often, to find out how can we tune this Materialized View. So the most common reason is that the query of the Materialized View is quite complex. So of course that query has to be fast, otherwise the query write would also be slow. Yeah, so that's a good question. So Sai, you can mark it.
Yeah, thank you.
How can we bring a DBA get to the root of any issues and find out what is the reason of staleness of a Materialized View? For example, with these 2 explain procedures I showed in the last part of the presentation. How can we avoid explain plan going for Materialized View query write if we see the performance degradation of our SQL query? I don't understand the question. How we can see that we have a performance problem without showing the execution plan or something like that does not make sense. So the execution plan is always the first thing I look at when I have a performance problem. That's the most important information to see what the optimizer does. Why are Materialized View logs growing too large, and when get they purged? That's also a good question. The Materialized View log, they contain all the information or all the changes that were done since the last fast refresh of a material, since the last refresh of a Materialized View. That means it's a kind of a journal table that contains all insert, update, deletes. And it is purged automatically when you do a refresh of the Materialized View. You also find some information about refreshing Materialized Views on one of my blog posts, which is also linked in this design tips part. But usually we don't have to care about the Materialized View log. They are purged automatically by the refresh procedures. That's also one of the questions you can mark as a good one. I was facing performance issue with Materialized View after upgrade from 11.2.03 to 11.2.04, a long time ago, hopefully. So after an upgrade of the database version, and we have opened a request with Oracle support. And he suggested to enable parameter complex view merging. Could you give me some more details that how this helps for Materialized View? I no clue. I think it's really for this special situation, because complex view merging, that's another feature that allows the optimizer to combine the select your select with the select of a view definition, not a materialized view definition. And I don't know your specific case, but if, for example, the materialized view contains selects on views, which is also allowed, then this would make sense. But I think it's too specific to answer here in this session here. So perhaps you can, yeah, I'll leave this open for the moment. Okay, then the next question, so 6 more, yeah, so we are almost at the end. What happened to query rewrite in case of Materialized View is stale? That's what I explained. So either we have to refresh it, or in this case, the base tables is used then. So if the Materialized View is stale, it is just ignored by the optimizer, and therefore query rewrite would not work till the next refresh is done. If we have real-time Materialized View with query rewrite enabled with stale tolerated, will it still get me fresh data? No, when the the question is, we have a real-time Materialized View, but we also set the parameter query rewrite integrity to stale tolerated. In this case, the optimizer says, okay, stale tolerated is allowed, and then it doesn't care about this complex combination of Materialized View and Materialized View logs for query rewrite. It would just use the normal query rewrite feature. So stale tolerated is stronger, so or has a higher priority than the real-time Materialized Views. In order to use one Materialized View for different distinct queries, which bitmap function should I use on which columns? So it's hard to say in general, but when you look at the Oracle documentation, one of the links in at the end of the presentation, you find some examples how you can create them. So they have several examples and explanations what functions you really need. Here it was just a short overview. I have not the time to explain it in detail. Once was on another conference, there was an Oracle employee, Richard McNichol, which had a presentation only about this feature, and they had a full session about about this. So that's something you cannot answer in 2-3 minutes. I want to use Materialized Views to have a list ACK function. Is this possible? Yeah, it is possible, of course. The question is, in which cases is it possible for query rewrite? That's something I never tried out. That's also a good question, I would say, and something it's interesting to find out in detail. So if you have some experience, then let me know. Contact me through my blog. And if I find some time, at the moment I'm very busy, but whenever I have some time, that's perhaps something I also can try out whether it works. So that's also a good question. So all questions are good, but I mean something more than what I just explained in the presentation. In case of table, the table size is big and a very high DML, so a lot of insert update deletes on these tables. Do you recommend to create materialized views? Yeah, that's also a good question, because it's always a decision, where do we want to spend time? So if we have a lot of queries on these tables and all these queries are slow, then the materialized view is good. But on the other side, whenever we do changes on the base data, then it also needs time to refresh this materialized view. So the question here is actually not mainly, is it recommended to create the materialized view or not? The question is more, what is the recommendation? How often should we refresh this materialized view? When we use the materialized view for a daily overview that is executed every morning, then it's enough when I refresh this materialized view once a day during the night or something like that, so every 24 hours. And then it can be a good solution, even if there are a lot of insert update deletes during the day. But if I read the current data all the time, and I don't want to refresh the materialized view every 2 minutes, or I could even do a refresh at the end of each transaction with a refresh on commit. But yeah, you really have to take care. I think in this case, in most, if it is really real-time data that is used, then I would probably not recommend materialized views, or perhaps in this combination with the real-time materialized views that I showed you how it works. How to enable trace for materialized view to find out why some of the queries are not using the materialized view. So there is no specific trace, or yeah, there are some internal traces, but the easiest way to find out what is going on in the background is that you either go through the AWR views, so the DBA hist views, or the $V views, that you see what queries were executed in the background. Or what is still a good option, although it's a bit old-fashioned, is that you enable SQL trace and then use the tk prof command to format the trace file, and there you see all the details. So for example, for a query rewrite, or also refreshes, what is executed in the background. What you don't see is the details, what is the reason why query rewrite worked or not at runtime, but with the enable, with the explain MView or explain rewrite procedure I showed you in the presentation, you find the interesting information there. But that's also I think I already mentioned it, that's a good question. And the last question, if we force hints in SQL query and using a materialized view with query rewrite, how to optimize the preferences between hints and the materialized view. So there is also a hint where you can force query rewrite, but as soon as you add hints, that also always means that the hints have a higher priority to what the optimizer will decide automatically. So if you have a hint that tells to use a specific index on one of the base tables, but the optimizer decides to use query rewrite, then your hint would disable the query rewrite for this feature. So yeah, you really have to take care when using hints, because that could have an impact. The query rewrite does not work as expected anymore. Okay, so I went through 18 questions. I think 4 of them I said they are interesting. I hope that's what you expected, Sai.
Yeah, thanks very much, Danny. I think I know how much busy you are, and still you committed to come and present with AIoG community. Thanks a lot, and definitely I'll catch you in upcoming months. At least this time I'll give you enough notice so that you can spend time with us. So thank you for your time. Participants, you can actually follow Danny in in Twitter, and especially the blog, and we will share the presentation tomorrow. You can find in the AIoG website, and please follow the links. It's very important. So again, thank you very much, and please connect in the Telegram channel if you have any questions. And congratulations to all this today's winners. Harihar, Prafulla, and Irwin, and Manikandan, thanks for asking the really good questions. Again, as Danny mentioned, every question is really good, but most of the answers are already covered in the presentation. But these guys are asked, out of the syllabus questions. Maybe that's why they have selected. So please prepare for even for the next session, right? So what's coming this Friday, starting with Anil Nair, is going to talk about Oracle RAC performance issues using AWR report. It's very important session if you are using Oracle RAC. And also we have Oracle Enterprise Manager, new features are coming up. So please all keep all your questions ready. And we have a security session, and the final session for this month is how to cheat for extreme database performance from the Douglas, right? So it's very important. Please join, share with your connections. And so thank you very much. Have a nice, wonderful day to everyone. And with that, we are closing this today's session. Thank you. Thanks, Danny, once again.
Also, have a nice day from my side, and hope that you that one day I can see you live in a in a face-to-face presentation, and not only on Zoom.
Absolutely. I think we are eagerly waiting, because we skipped the last year's Sangam, and we are eagerly waiting for this annual event. And, definitely, yeah. Thanks a lot.
Have a nice day to everybody.